Hello everyone, I am Mr. Mahmoud Abdullah, and today we will have a math session about quadratic function. Quadratic function is the first LO in semester 2, and we will continue in this session the concepts about the first LO quadratic function. At the beginning, we have explained how to determine the degree of the function from the first degree or second degree from the first or second difference, the first and the second difference. After that, we take the different shapes or the different formulas of the quadratic function. The quadratic function have three formulas. The standard formula, f of x equal ax square plus bx plus c. The vertex formula, f of x equal a open arc x minus b close the arc all square plus c. The final shape of the quadratic function is the factored form, which we can write it f of x equal x minus b times x minus c. And also we have taken the method of completing square. How to complete a square? To convert the standard form or the factored form to the vertex form. I will suppose we have a quadratic function in its vertex form, f of x equal a x minus b all square plus c. This is the vertex form, and we can get the vertex point of the parabola curve. The first concept today is the parabola curve, and the parabola curve is how to graph the quadratic function in the Cartesian coordinate. This is a parabola curve, and this point called the vertex. This is the symmetric point of the parabola curve. How can we get the vertex? How can we get the coordinate of the vertex, x coordinate and y coordinate, from the vertex shape? At this vertex shape, this number b is the x coordinate of the of the vertex point. Then this point, x coordinate is b. Y coordinate is the constant here, which equal c. Then y coordinate here will be c. Then the vertex point here in this formula is b and c. We noticed that a here, the coefficient a, doesn't change the vertex point. The vertex point depends only these two values, b and c. Okay, now we take some information about parabola curve. We know that the parabola curve open up when this coefficient is positive number, and open down when this coefficient is negative, open down. We have also, if we know to determine is this equation have a real roots or imaginary roots, have no real roots, from the sign of a and c. If a and c has the same sign, both are positive or both are negatives, then this equation has no real solution in R. R is the real number. But if A and C has a different sign, one of them is positive and the other is negative, then there is a real solution for this equation. Okay, now we will take another characteristics for the parabola curve. Another properties. The vertex point, we have taken it, the focus point, and the directrix line. The focus point and the directrix line is some properties of the parabola curve. This point inside the parabola curve called focus point, and this line, this horizontal line, is a directrix line. This point and this line has an important property. If you take any point in the parabola curve, then the distance between this point and the focus point is equal, must be equal, the distance, the perpendicular distance between the same point and the directrix line. This two distance must be equivalent. Then the focus point and the directrix line has an important property, that the distance between the focus point and any point on the parabola curve is equal with the distance between the same point, the perpendicular distance with the same point and the directrix line. How can we get the focus point and how can we get the directrix line which will apply this property? We will begin with the focus point. How can we get it? How can we get the coordinate, the x coordinate and y coordinate of the focus point? We will suppose that we have the function on the vertex form. This is the function, the quadratic function on the vertex form. This is the coefficient a, this is the coefficient b, and this is the constant c. We said that the vertex of this equation will be b and c, as we wrote. How can we get the focus point? We notice that the focus point is at the same vertical line which passes with the vertex point. If we draw a vertical line, this vertical line will passes with the focus point and also will passes with the vertex, and that means the x coordinate of the focus point is the same x coordinate of the vertex point, because they both passes with the same vertex line. Then the focus point x coordinate will be the same vertex, this will be b. Then the vertex has the same x coordinate with the focus point. Now, how can we get the y coordinate? We can get y coordinate if we know this distance, this vertical distance between the vertex and the focus point. This distance, I will call it P. For example, P, any letter. Then this distance is B. If y coordinate here is C for the vertex, then y coordinate for the focus will be C plus B. I will explain it more clearly in this part. If you know that this point have two coordinates, its x coordinate equal 2, and its y coordinate equal, for example, 1. Okay, then this point equal 2 and 1. If you know that there is another point lies in the same vertical line with this point, but above it with a distance, and this distance, for example, equal 1 centimeter or 1 length unit. Can you get the coordinate of this point? Yes, you can, with an easy way. Because it lies on the same vertical line, it will have the same x coordinate to this point, because they lies in the same vertical line. Then its x coordinate will be 2. Its y coordinate will be what? This point has y coordinate equal 1, and this distance, which is which between the 2 points, this distance is 1. Then this coordinate must be equal 2. How can we get 2? We add this distance to this coordinate, and it equal 2. That we have made in the vertex and in the focus. Focus has x coordinate equal to the vertex and has y coordinate equal. The same coordinate of the y of the focus plus the distance between the focus and the vertex point. Now, the focus point will have a coordinate b and c plus b. B is the distance. How can we get it? How can we get this distance? This distance has a law to get it. And this law depends on this coefficient. The coefficient A. The coefficient A in the vertex form, not the coefficient A in the standard form. We also know that the standard form f of x equal ax squared plus bx plus c. This is a different form, and A, which I mean, which is a distance, depends on not this coefficient in this form. No, I mean A in the vertex form, because we can convert the vertex form, the standard form to the vertex form. So A, which I mean, and which I will write in the law to get B, depends on A in the vertex form. B, the distance between the focus, the vertical distance between the focus and the vertex, B equal 1 over 4A. 1 over 4A. Then we can get the focus point if we have the vertex form. The final property in the parabola curve, the directrix line. Make attention, the vertex is a point, just a point, have x and y coordinate, ordered pair. The focus is a point. The directrix is a line, is a horizontal line. This horizontal line, as we said, if we take any point, it will have the same distance perpendicular to the directrix and between the focus. How can I get the directrix line? By the way, because the directrix line is a horizontal line, it has an equation, and this equation will be y equal number, because it is a horizontal line. The horizontal line equation is y equal number. The vertical line equation is x equal number. Then this vertical line, this horizontal line will have equation y equal number. How can we get this number? With an easy way, very easy way. We know that the distance between the vertex and the focus is equal to the distance, the perpendicular distance between the vertex and the directrix. So this distance are also b which we get from this law. Now you can get the directrix line equation. Y equal, if we suppose that y coordinate here is C, that means this point will be C. This number will be subtracted with B. We will subtract B from this number. Then the equation of the directrix line will be y equal C minus this distance, because this point is lower than this point by a distance equal B. Then y will be equal C minus B. And this is the equation for the directrix line. Then the vertex is a point, has two coordinates. The focus is a point, has two coordinates. The directrix line, the directrix line is an equation. Y equal, if we suppose that the vertex point are A and B, B and C, as we wrote in this equation, the focus will have the same x coordinate and will be here C plus the distance B, and this directrix line will be y equal C minus B. If we suppose that this curve will be open down, this curve will be open down if the coefficient A is a negative number. In this case, the vertex point will be here. This is the vertex. And the focus will be lower than the vertex. The focus point will be lower than the vertex. And the directrix line will be above the vertex. So this distance is B and this distance is B. If we suppose now that the vertex point is B and C, then the focus point will be B and C minus B. C minus B. Okay, minus the distance. If we suppose that is absolute value for the distance, we will subtract it here, and then the the directrix line will be y equal C plus B. C plus B, because the directrix line is above the vertex. This is how can we get the vertex, the focus, and the directrix line. The inverse of function. How can we make an inverse of function? F of x here is y. If we inverse the function, we'll inverse it, it will be a new shape. It will be x equal a y minus b square plus c. But with another numbers, if we inversed it, these numbers will be different. I suppose we have a new equation, and this equation is an inverse for the quadratic function. Its shape will be like this. Its shape will be like this. This inverse is not a function. It's not a function because the vertical line will cut it in 2 points. Now, this value is the vertex. We will suppose it B and C. Okay? Where is the focus? This is the focus now. And this is the directrix line. The distance between the focus and the vertex is equal the distance between the vertex and the directrix line. Now, the vertex point is in the same horizontal line, not vertical. It's the same horizontal line with the focus, so that it will have the same y coordinate. Then the focus y coordinate will be C also. Notice for the difference between the function and the inverse of function. Here, the focus has the same x coordinate with the vertex. Here, the focus has the same coordinate y with the vertex. The x coordinate will be changed. The x coordinate here was b, but now we will add this distance to b. Then the x coordinate will be b plus p. Now, the directrix line. The directrix line in this case, in this inverse function, will not be y equal. It will be x equal, because this is inverse of the function, and the directrix line now is not a horizontal, it is a vertical. And the equation for the vertical line, x equal number. What is this number? You can tell me. What is this number? X equal what? This coordinate is b, and this distance is b. Then this coordinate will be b minus b. B is the coordinate of the vertex minus the distance, and we know how to get this distance. B is equal 1 over 4a depends on this coefficient. This is the inverse of the function. Okay? Now, we has explained if we have the function, how can we get the vertex and the directrix line? What about if we have the focus and the directrix line? How can we get the equation? How can we get the equation? Let's take example for this. Let's take an example. I will give you the focus and the directrix line, the directrix line equation. I will give them to you. And you must give me the equation in its vertex form or in any form. We can convert it. We will take an example. A parabola curve has a focus which equal 2 and minus 1. This is the focus. This is the focus. And have a directrix line. Directrix line, its equation y equal, not x equal, because this is a function, not an inverse to the function. Directrix line y equal 3. Now, get the quadratic equation of this parabola curve. We want to make the equation, and we have the focus and the directrix line. This is the focus. I will suppose to explain the method. The focus is 2 and minus 1. This is the focus, 2 and minus 1. The directrix line is y equal 3. This is the directrix line. This is 3, and this is the directrix line. The directrix line is above the focus. That means the parabola curve is open down. The parabola curve is open down. Now, if we take any point, in the parabola curve, we know that the distance between it and the focus equal with the distance, the perpendicular distance between it and the directrix line. These two distance are equal, which we called it B. Now, we will suppose that this point coordinate is x and y. Then, the distance between x and y and 2 and minus 1 is the same distance between x and y and this line. We will make an equation to these equivalent distances. The first distance between this and this, we will make it by the law of the distance between 2 points. You will make this law. You remember it. The law of distance between 2 points. X minus 2 all square, y plus 1 all square. This is the distance between this point and the focus. We will equal them with the distance between this point and the directrix line. This distance equal what? This perpendicular distance. It equal the difference of y coordinate between this point and this point. Y coordinate for this point equal y. Y coordinate for this line equal 3. Then this distance is equal 3 minus y. 3 minus y, or y minus 3, because we will put it in absolute value, because the distance must be positive number. This is the method which we will get the equation by squaring the two sides. We will make a square to the two sides. Square that and square that. If we square that, the square root will be eliminated, and we will get x minus 2 all square plus y plus 1 all square. And when we square this absolute value, it will be y minus 3 all square. Now we can expand this arcs by the law of perfect square. We will expand this, we will get x square minus 4x plus 4, and we will expand it with the same law, perfect square. We will get y square plus 2y plus 1, and we will expand this perfect square. We will get y square minus 6y plus 9. This is the equation, but we want to simplifying it. Y square will be eliminated with y square, and we will try to get y in a specific side. We will get minus 6y to the other side. It will be 6y plus 2y plus 2y, and we will send all the terms to the other side with a negative sign, with the opposite sign. This will be minus x squared, this will be plus 4x, this will be minus 4, and this will be minus 1 in the right side, and this number didn't change, equal 9. Now we will add these two terms. It will be 8y, and this term will be minus x squared plus 4x, and we will add this constant, minus 4 minus 1 equal minus 5, minus 5 plus 9 equal positive 4. Now we can get rid of this number 8 by dividing the whole equation by 8. Then y will be equal minus 1 over 8 x squared plus half x plus half. This is the final equation for the parabola curve in the standard shape. This is the standard shape, and we explained in a previous sessions how to convert it to the vertex shape if you want to get the vertex shape. I hope this session was useful for you, and meet you in next session.